So below is a table showing the average heights in centimeters for girls aged 7 through 15. And you can see I've got 7 up to 15 and I have the different average heights. Leroy calculated the least square regression line for the data and he found it to be y equals 85.5 plus 5.22x. He feels that is a good model for his data. Use residuals to either confirm Leroy's belief or to convince him otherwise. Leroy also thinks he can use the least square regression line to estimate the height in centimeters of his 27-year-old cousin Matilda. What do you think? Be clear and complete. So obviously this is a question that if you get to it and you have time at the end, it's a question that I could spend a lot of time on, and it's a question that I could probably get a fairly good score just spending a little bit of time on. But if I want to be clear and complete here for this example, I would begin with modeling the situation and getting the data in myself in a calculator. So I have let me bring over the larger calculator display also. So I've already entered this data accurately. So if I hit stats and edit, you can see I've already got the 7 through 15 in the first column, and then 120, 125, 130, 38, and I think 138, 143, 150, 155, and then 158, 158. Yeah, so it's all there. And I could go ahead and look at it. I'll look at it as a scatter plot. So I'll hit second scat plot, the stat, and then I need to turn it on. So there's plot 1, and I'm looking at list 1 list versus list 2. And I'm going to just press zoom and 9, and there I can see the data. Now, one of the things that's pretty clear to me just looking at this data is that there seems to be something that's happening, towards the end here. So I don't know that I feel super great about a linear model for this data. Let me drag this picture and I'll just keep it here. So just the fact that there's a curve on this towards the end, to me, tends to indicate that probably a linear model may not be the best thing. So to confirm that, I'd like to look at the residual plot. And to do that, I'm going to go ahead and figure out the least square regression. I'm going to do get the line of best fit myself. So I'm hitting stats calc, and then I'm going to press 4 and enter. And I can see that I have, yeah, exactly what he has, 5.22x. And then there's also, ooh, that's interesting. I have 84.5 and he had 85.5. So I think I could say his model's off a little bit, but that's pretty insignificant. That's just his y-intercept looks like it was copied down wrong when this question was typed up. And that's bad, but I think it could get worse than that. In fact, let's add that line of best fit to the data. So I'm going to hit y equals, and I remember that this equation stored in vars, so it's a statistics variable, and it's an equation, and it's the last regression equation that I ran. So if I hit graph now, I can see there's my data, and there's the least square regression line that's shown on that data. Well, as I look at it, it's actually pretty close to the line, right? I could probably figure out the correlation coefficient, and that would be strong as well. I don't have diagnostics on, so let me go ahead and figure out the correlation coefficient. I'm going to hit second catalog, and I'm going to jump all the way down to the letter D's, and I need to find diagnostics on. There it is. So I'll press enter, enter. So diagnostics is done. So now I'm going to do my linear regression again. Calc. There we go. And when I do it this time, let me pull this over here. I have, you can see the, oops, let me pull this, make it a little bit larger. I can see that my correlation coefficient is very, very strong, right? So there's a positive association, and my correlation coefficient is 0.99. So to me, I would say based on those two things, it looks good. But here's the thing. Over this short span of years, from girls age 7 to 15, I think this is probably a bad model because I know for a fact that most growth happens, in that window of time, and people don't continue to grow at this rate. So if I'm basing my rate of growth on the time when humans grow at the fastest rate, 5.22, as I guess centimeters per year, that's problematic if I try to extend that outward to a 27 or a 30-year-old, right? In fact, if I was to plug 27 into this um, function and get the number of centimeters out and convert it to feet, I think this probably person, Matilda, would be pretty tall, right? Maybe 7 feet. I don't know, but I'm guessing she would be tall if this growth rate persisted. So one of the things that we use to help us to decide whether or not a line is a good model for a data is we look at residual plots. So I'm going to look at the residual plot for this data. And again, I've already run my linear regression, and I'm just going to go into my list, and I've got my x's, ages, and I've got the y's, their height in centimeters, in list 1 and 2. In list 3, I'm going to add all the residuals for this data set. So to do that, again, they're stored in a special list. I'm just going to say list 3. You can see my cursor's up on the top there. It's going to equal list, and it's the very last one, list number 7, which is my residuals, and I press enter. So this is beautiful. I've got all the residuals on one graph. And now instead of looking at the scatter plot, which I did over here, I'm going to look at the residual plot. And to look at the residual plot, I'm going to switch. Instead of looking at list 1 versus list 2, I'm going to look at list 1 versus list 3. So I'm going to just clear this and hit second list 3. And now I'm going to hit zoom and fit it again. So now I'm looking at my residual plots. I'm going to drag that over here and make it a little bit larger. So here's the thing I want to look at on the residual plot. You can see this, right? You can see that the growth rate it's low, and then it goes high, and then it goes low again. I can see this pattern, right? Well, I know for a fact that, yeah, that's what happens with humans as they're growing too. So based on just my observation about what we're talking about, human growth, and I would say that a linear model would be terrible for this data, because what the linear model is doing is it's projecting out, if you looked at the line of best fit, it's projecting out unreasonable heights. These are just extraordinarily tall humans, and we don't see this in the population because human growth curtails, and towards the, I guess I don't know what it is for boys or girls, but certainly by the 20s, the growth rate is definitely slowed off. So I would say based on these observations that a linear model would not be good. Based on the residual plot, a linear model would not be appropriate. And you could definitely sketch the residual plot and have that in your answer. You could, kind of explain why you feel that the residual plot wouldn't be great for this. So there's a lot of different things that you could do or say for this problem, and just, tell me something about it. Tell me something about residuals. Show me that you understand um, what's going on, basically.